Right. So as I said, we started to take a look at gas laws, right? And there were three gas laws that we talked about. The first guy was Boyle's law, nice. And then after Boyle's law, we looked at Charles, and then we have pressure law. Boyle's law, general gas law, yeah. So Boyle's law, we saw that pressure was inversely related to volume, and the formula was P1 V1 is equal to P2 V2. Charles' law. Charles' law, we said that volume was directly related to the absolute temperature, and the formula is V1 T1 is equal to V21 T2. Please remember that T is in Kelvin, right? And pressure law, we saw that volume was directly related to temperature, and the formula would be P1 T1 is equal to P2 T2, right? While we're here, we need to remember something that's important, right? In Boyle's law, what was constant in Boyle's law? Right? Temperature was constant. What was constant in Charles' law? Pressure, nice. Yes. And the last one is volume. Right, so you need to remember when to use the laws by taking a look at what's constant, right? So volume constant. And then there is one called the general gas law. There is one called the general gas law, right? That's P1 V1 is equal to P1 V1 and T1 is equal to P2 V2 T2. That's the general gas law. Okay, so these are all the laws. You have some small questions to do for me. Check the handout. I sent you some small questions. I have some small questions there for you to do.
When?
No, that was the old time in the handout.
Oh.
Copy that down fast. Then make it around use the washroom. Right, and you have some questions here to do. I'll just put up the handout fast. Oh, this airdrop thing is still not. Yeah, it's mineral about it. Right. So in the handout, I'm not sure if you all did it. I think I asked you to do it, but I'm not too sure. No, I didn't. Okay. All right. So you have these little questions here to do for me, right? What's the first one? What's the law you're going to use for the first one? Constant pressure. So which law are you using? Next one. Constant pressure. So which law is that? Charles. Next one. Constant volume. Which law is that? Pressure. And the last one. Sorry. Third one. Constant temperature. Boils. And the last one. General gas law, right? Take your time, use the formula and work out after. Temperature must be in what? Temperatures must be in Kelvin. Good. Right, so we have 4 to work out. Hurry up. Right, so today our focus is that only, right? We're only focusing on gas laws today. Yeah, we're doing the Kahoot in a little while. If I'd give it before you would do bad what? Or I didn't write out the formulas for homework. Right? I'd give you those formulas for homework. Yeah.
When he says to do something, they want to do it right. Paul is studying that one that what he says. Yeah. Keep saying it. Write it up.
One time. Yeah, Jacob actually do it. See, I can did one of them at least. 1 or 2. All right, come on. Do those calculations first, yeah? Right, those who online message your answers, right? As soon as you do it, just message where you get for E, where you get for B and C. Right, so to finish online message answer. So you should be done with the first one. Could I attend the first one? Yeah, okay. Let's make sure you're doing it properly. Hold on. My pen is not working. I'll take it off. That my pen is dead. All right. So now let's check out your first one here. All right, so just doing A for you. As I said, constant pressure means we're using Charles' law, right? V1, T1 is equal to V21, T2. The first volume is 5, the first temperature is 245. Is the temperature in Kelvin? Right, so you're good to go. You don't have to do any changing, right? V2 is 10, they wanted to solve for T2. Two fractions equal signs, so you cross multiply. Say multiplying 5 by T2 and 10 by 245. So that's 24550. So T2 is equal to 2450 divided by 5. How much is that? 490 Kelvin. You all got that online? 490 Kelvin. Cameron, you all got that? Ishana, Katrina, Maria, Sahara, Shannon, Mirage, Malini. You all got that? So in a similar way, okay, good. So in a similar way, I want you all to work out part B, C, and D. Right? Message your answers as soon as you finish B. Raj, message your answer for B, right? You follow part E, Raj? All right, so do part B, C, and D. So once you finish, message your answer for part B. Nice, Maria sent hers already. Right, Voraj answer now. Got it again, sure. Right, send your answers to B. Cameron, Shannon, everybody else online, send your answers to B. Well done. Ishana, you too. Malini, I didn't get yours, I think. Cameron, I didn't get yours. Right, you're finishing next to. Right, so constant volume is what? Constant volume is pressure law. P1 T1 is equal to P21 T2, right? So P1 is 125, T1 is 245. Next is 150 over T2. Cross multiply, you'll get 125 T2 is equal to 150 by 245. So T2 is equal to 150 by 245 over 125. How much is that? How much you get it? 294. Yeah, see, most of the answers is 294. Good job. 294. Oh, thanks. 294 Kelvin. 294 Kelvin, right? Next one. What's the next law we use in here? Malachi. C is which law again? Boyle's law. So that's P1 V1 is equal to P2 V2, right? And they gave you P1 as 25, V1 as 25 as well. And they said V2 is 60. Solve for P2. So what's that? 25 by 25 all over 60. How much is that? 10 point? 10.42, right? 10.42 pascals, right? And watch, when you all look at the values, right? When you all look at the values, you should have an idea if it should be bigger or larger. the volume went from 25 to 60. So if the volume increased, the pressure should what? The boys law decrease. Very good. So the pressure value should be smaller. So if you get 10.42, that's a good sign that you got a negative, that's a decrease. So your answer should be right. Anybody else got 10.42? Yeah, nice, Sahara. Do the last one quick. To do the last one quick there, right? The last one is nice, Shannon. Last one is general gas law. Do that fast, message your answers. Right, those who online message, once I get it. Cameron, did I get any answers from you? Is it Cameron, are you there? All right, send your answers, Cameron, please. All right, so just to give you an idea of how to use the rules, right? Based on what you have, if it's what constant, you can figure out which laws. Nothing constant, general gas law. While you're working, there's something I want to note, right? If you learn the general gas law, and you recognize temperature constant, then all you have to do is this, take off temperature, and you will see that they're using Boyle's law, right? If on the other hand, volume constant, take off volume, and you will see you're using pressure law. So if you know one law, it should help you figure out all the others, right? Send your answers of P2. Have one so far. Get in the habit of writing the SI unit as well, right, Ollie? They ask a temperature, so try and give them the answer in Kelvin. What you get, Ricardo? Let's now check it. Shannon, check back yours, looking a little too small. Come on, are we done on yours? All finish? Which one again? All right. Just waiting on Cameron before I work it out, right? Cameron, you ready as yet? Right, send a picture what you have so far, Cameron. Let me see what you have. Right, good job, Katrina. Yeah, you can send it on WhatsApp. So, what you having problem with making T2 the subject of the formula? So we have P1 V1 is equal to T1. All right, watch this here. In case you get in trouble with that, right? P1 V1 on T1 is equal to P2 V2 on T2. What do we need to make this subject again? We're trying to find temperature, right? Right? So we're trying to find temperature. So you have two fractions separated by equal signs, so cross multiply. P1 V1 is T2 is equal to P2 V2 T1. Right? So you're making the subject of the formula, right? And then you want to make T2 the subject. So divide by P1 and V1 here. Same thing here. It'll cancel off here. And you will get T2 is equal to P2 V2 T1 all over P1 V1. Just to plug in the values now. P2 is 550. V2 is 10. T1 is 245. P1 is 225 and V1 is 25. Right? So what did they do? They made the volume smaller and they increased the pressure. All right, good. So what you all got here for T2?
I got 240.
239.6 sounds very good. Very, very good. All right. So nice. Yeah, that could work if you want to 240, that's correct. But I didn't have to say wrong, that's all I wanted. Everything.
So it's not 239.6, it's 239.5.
Yeah,
Oh.
but it's 6 right now.
It's 5.
I'm sitting right there. It's 6 more.
So it's 239.5555.
Right, so still it's still 0.6. It just coming to mass or one. By stop coming to the mass. All right. Right. Before we jump to the past papers, I'm not sure if I gave you all the graphs last week. No? Yeah, you get the quiz just now. All again, all the quiz just now. You don't need the graph book. Watch this here. For Boyle's law, right? We said that pressure was inversely related to volume. So if here's pressure and here's volume, the graph looks like that. Right? It's important you understand the relationships, right? How they look. Right? Then you have Charles' law. Charles' law of volume and temperature directly related. How did this graph look Kilan, if they're directly related, how will the graph look? Look at inversely. Inversely one on top. Right? Good job, Jacob. It'll look like that. Yeah.
Yeah.
Right? And then pressure law. Pressure proportional to temperature. This graph should be familiar. I showed you all this graph, remember? When we were talking about the Kelvin scale at the beginning of this topic. All right. Jot down those graphs fast. Right? Those are the graphs of Boyle's law, Charles' pressure law. Cameron, if you follow the last one now. Oh. Which two? Coming on, make sure coming on say again. I was seeing play well, but I come to our game for sure.
Who, me, sir?
Yeah. Where is it? Where is it?
I was saying, shut up.
Where is it?
Well,
Where is it?
oh, Marla.
Well, which one?
You know,
I'll go and train and we will play all one and one in the avenue. Right?
now, sir, the father,
Huh?
after men get started.
Oh, yeah, you got to go. Tell them my day we will go the league in the hot sun.
Yes,
So we support.
By the police station. Marvel.
I think it's gospel. Yeah. Yeah, come on, they have you up there. One of you, you do all 2 and 2. Well, I'm going to say, after like what picture they not. And Reginald, we do push, keep it up.
Real?
Yeah. Yeah. Oh, you have some different.
So boxing look come. He's come sometimes. There. Oh, wait. I probably don't know him. But I know he was there when coach wasn't there. All right, good. Let's try one little pass people. I want to Kahoot first. No. But I got possible for sure.
Yeah.
So you're leaving the Kahoot for last time. All right. Let's take a look at the past people here. Anybody else join online? Karina, you have all this, right? All right, so the next thing we want to do, we want to take a look at a small past paper, right? Nice, easy past paper. Whenever you're Yeah. All right. You all seen it? You all seen that there? Oh, wait, that's still sharing this to the wrong screen. Okay, hold on. Huh? Let's share this version of it. Okay, the question can go back to front, right? But take a look at the first one there. A piston traps a mass of gas in a cylinder at 25 degrees Celsius. Once you see temperature in degrees Celsius, what do? Nice. Pressure is 5 atmospheres and they give you the volume. Calculate the volume if the pressure drops to 1 at constant temperature. So which law is that?
Boil.
Constant temperature means they're using Boyle's law. Go ahead, have fun, try that fast. Take your time, right? Take your time. And remember that you could also work in right? It's okay to work in atmospheres and things, right? And milliliters. Just all temperature must be in Kelvin. Very well good. Take down the question and just write down the important things. Work it out. Right, message answers. So now you finish. Nice, Cameron. You check it us now. So when I finish tomorrow again, right? Finish already? Huh? No, you work it out. I'm waiting on you. Hurry up. Ishan, how much you got? Okay, got you. Right, so you all said boys law, right? So P1 is 5, V1 is 50, and now the pressure dropped to 1. So you had to find for V2. So 250 is equal to V2. So your new volume is 250 milliliters. Kilo, you get that? Huh? Are they still working on that? Anybody else got that online? Good job, camera. Very good. Baraj, you got you there? Anybody else got those values online? All right, use the wrong rule. So remember, the hint for the rule is constant temperature. It gives you an idea which rule to use. And as I told you, in case you're not sure, write down general gas law. You should at least learn this one, right? And then this is temperature constant. Take it off. All right, copy it down. Let's do the next one. All right, next one, right? The next one has to do with same question, right? So you'll need your values, right? After resetting the piston, the gas returns to its initial pressure and volume. Right? The initial pressure was 5 atmospheres and the original volume was 50. Right. If the volume is now fixed with a while the gas is heated to 60, find the final pressure. What was the initial temperature again? The initial temperature was 25, right? So your T1 was 25 degrees Celsius. Hurry up. Try that, Malachi. What are you doing? You don't need your phone, Malachi. It's like a calculator there. Take it up. Hurry up. Try this one here. So they said the volume is now fixed. So which law is that? Which law is that, Sahara? Sahara, which law is that if the volume is now fixed? Sahara, you there? Which law are we using? Boyle's law, because volume, no, they said volume constant. Just look back at the laws he wrote down. It's real simple. Look at the laws he wrote down and look and see when it's constant, which law is that? Yes, Sahara. So which law is used when the volume is constant? Nice. Oh wait, Katrina, good. Wait, no, Sahara. Yeah, go ahead and work it out, everybody else. Sahara, which low? Huh? Yeah, you're using the first temperature they give you. Yes, Sahara. Check my kilos. No, general gas law is when nothing constant. Check again. Did you wrote down all the laws? Keelan, you finish with work out this? Sahara, you're calling out all the laws, the pressure law. Did you write down all? I just wrote it down here. I wrote down all the laws and what constant. If you look next to pressure law, you will see volume constant. Right? So it means that you're using pressure law. Okay, so you're using pressure law. Hurry up. Use pressure law and find the final pressure. Temperature must be in what? Kelvin, right? Yeah, that's 50. That's my last one. Yeah, it's 50. And the temperature is what? 25 plus 273. Your final pressure is what you're trying to find. Your final temperature is 60 plus 273. Right? So cross multiply and solve for P2. So you'll get 50 by 273 plus 60 is 333. And then 25 plus 273 is 290. How much you get it? For the final pressure. How much shall I get it? How much? 55.8. Anybody else get it? 55.9. So it's 55.9. Right? Atmospheres. All right. Before we do our next one, let's take a look at this Kahoot here.
I do one time and do this one. I think this is
All right, hold on. But you and I here. Well, those who are online, some of you are not responding and not sending anything, right? I need to see your answers. If you get in trouble, just take a look quick at how far you reach and send it, please. Or just message a question. Right? Some of you are not responding, so I want to show how you're doing, right? Sahara, do you have all the laws now?
Now on to
All right, next one here. Right, next one. I have the year for this one, right? This is 2016. This one is 2016. It's kind of simple, right? But it asks you to verify the laws. 2016, number 3.
yeah.
Huh? We're talking about. Now, and so you want one more? What's that? Huh?
It's something appraised, man.
All right. So if you watch here, right? If you watch here is volume, right, they give you the apparatus here for checking pressure law, right? And they ask you some small questions here. Try that fast. Part 1 is to complete the Kelvin, and then is pressure law supported. Try that fast. Yeah. Hurry up, work it out in Kelvin quick, and then we will talk about that.
I would like to answer.
Work it out in Kelvin and then tell me, does it support? Right, so we shouldn't take too long for this one. What is the pressure law? What is the convert to Kelvin here from Karina? What you got for the first one? How is convert to Kelvin again? Right, you add in 273. Karina, can you help me out here and just tell me the values there? Nice. Karina said 308. That looking good. What's the next one? 336. Very good, Karina. And the last one. 364. Good. Right. Let me pick on somebody here. Malachi. What would you say? Is the pressure law supported, and why?
Yes, I would say the pressure law.
Right. You're saying yes. Why?
So pressure law calculation to take place. We need temperature and pressure, and we have to.
All right. We have temperature and pressure, right?
But
Why is the law? Why is the law supported?
Followers.
What? But just, no, it's something important. What we know about pressure law. Ricardo, pressure and temperature are what? How are they related? How is pressure and temperature related? Pressure and temperature is inversely. No. Versely, no. Directly, yes, directly. Pressure and temperature are directly related. Right? Think it long.
Yeah.
All right. Yes. So I need somebody else to help me, please. I need it. So the answer is yes. I'll take yes, but I want an explanation. And anybody online want to try? Pressure and temperature directly related. Right, Malini? Correct. But how does the value show that? That's what we need to get. How does the value show that? As the what? Go ahead.
The pressure increases as it is going down the table.
Right, as we go.
Temperature, increasing as well.
Right. So as you go down the table, the pressure increasing, and the temperature also increases. Marka, you on your phone now? Oh, okay. All right. So as you go down the table and the pressure values increase, the temperature values also increase, which shows that they are directly related, right? What will the graph look like? It's 5 marks. You gotta give them some more.
Well, sir.
It will be a directly proportional. Very good. Okay. All right. Let's do a Kahoot fast. Share this quick. You cannot share. Yeah. Push up to your phone. It might take too long, so share, pick somebody and they will help you. Pick somebody now. Right, log in fastly, Olive. We don't have much time. I'm doing back the same Kahoot at the beginning of the next class. Huh? Well, I'm hoping so. Come scan and log in quick now. Scan and log in quick.
Can you try to avoid having to join a class? You think that he's so smart.
Hey, no, log in, hurry up now. Where? Oh, look at this scan and log in. Take phone now. Ishana, you logging in? Malini? Right. We're just waiting on, oh gosh, where you going? Kill on.
So you visit in your class.
His phone not there? Huh? All right. No problem, Melanie. Come fast now, waiting on you. I want to start. Scan it fast and log in. All right, let's go. What's up? All right, let's go.
So just one up. All right.
I'm not killed on boy. All right, let's go. Start. Gas laws, right? All right. We that finished already? Where is some? Oh. All right, let me see. Shannon, is Shannon leading here? All right, next. I get how much time in this one? A short nip. People get that wrong. Right, come. All you say should be all right. True or false? It's not tricky though, right? Did I catch some all over this one? Answer is true. Right? I switch it around as 1 on V, right? So that's why I was directly. Very Varaj. Nice job, Varaj. Yeah. Temperature constant in Charles law. True or false? False. Someone put in false. Why we just do this, man? Katrina. Anybody here on the first page? Anybody here on the first top 5? Katrina running the rules here. Pressure law, that's correct. Wait, now when you give it a true or false, I'll add one more for next week. Some calculations. Right, that was much better. No change. Katrina still on top. 2 more. General gas law is used when what? Very bad, Oli. Very, very bad. 6 people said temperature constant. Huh?
Should I turn? I get correct.
Katrina, get it right. Last one. Spell it properly, right? Lowercase. Spell it properly, all lowercase, nothing else, right?
Obviously.
9 seconds. 5 seconds. All right, next day I'm going to give you back the same thing and add on more. Let's see the top 3 today. Maria, good job.
Sergeant, top 5. Hey,
Shannon, good job.
top 5.
Who was top here? Katrina, very good. Let's see who was 4th and 5th. Malachi. Whoa. All right. All right, so make it a little top 5. All right, so nice. So online, next day, no homework, just revise the summer, please. You're gonna get back gas laws with some calculations. We'll do a couple past papers and then move on to thermal quantities. All right, so that's it for today. Online, you all can log out.
So you are already.
All right, I'll see you all next week. Some of you all see tomorrow, some I'll see Saturday. Saturday I do electricity, right?